Morning everybody, my name is Komal. I am currently pursuing my BTech in Aeronautical Engineering from University Department, Rajasthan Technical University, Kota. The topic of my seminar presentation is Aeroelasticity, which I have completed under the guidance of Dr. S. Choudhary. So let's start with the first slide. These are the contents of my presentation. Firstly, I am going to explain what is aeroelasticity. It is a term concerned with the interaction between the deformation of an elastic structure in an airstream and the resulting aerodynamic force. Aeroelasticity regarding aircraft structure is defined as the branch that investigates the phenomena that emerge due to the interaction of aerodynamic, inertial, and elastic forces emerge during the relative motion of the fluid and the flexible body. It studies, analyzes, and harnesses the interactions among aerodynamic forces, structural deformation, and motion of aerodynamic and hydrodynamic lifting forces. More specifically, it is used to address issues related to flying vehicle. In the next slide, I will first explain about what is aeroelastic phenomena. Aeroelastic phenomena arise when the structural deformation induces additional aerodynamic forces. Air vehicle is always subjected to aeroelastic phenomena. Many items, parameters like its large aspect ratio, thin airfoil section, high speed, and unusual shape cause special aeroelastic effects. Moving on to the next slide, this is the flowchart about the aeroelastic phenomena. Aeroelasticity have two different phenomena. First is static aeroelasticity that includes divergence and control reversal. And second is dynamic aeroelasticity that includes flutter and buffeting. In the next slide, I will explain about what is static aeroelasticity and what are its different phenomena. Static aeroelasticity is concerned with the balance of steady aerodynamic loads and elastic structural forces. The first static aeroelastic phenomena is divergence. So the divergence is an instability issue. The wing generates more lift due to elastic twist than the structure can resist. For a small input, divergence leads to a large angle of twist. Elastic twist of the wing suddenly becomes theoretically infinite. It occurs when the moments due to aerodynamic forces overcome the restoring moments due to the structural stiffness, so resulting in aircraft failure. The second phenomenon, that is control reversal. It is the static aeroelastic phenomenon that is contrary to the torsional divergence. It does not cause the loss of stability but rather cause the loss of maneuverability. Control reversal is where the control surface fails to develop the desired increment in lift above the reversal speed. A control input produces lift or moment opposite to that intended. In general, this reversion may occur on any control surface. However, it is typical for the lateral control system, that is aileron, because the ailerons are placed in the tip region of the relatively flexible wing. Another but the highly rare option is the reversion of the elevator due to the low stiffness of the fuselage, which may occur with the unconventional aircraft with the tail booms. Next, we are going to talk about is dynamic aeroelasticity. So the dynamic aeroelasticity studies the interaction among aerodynamic, elastic, and inertial forces. It generally causes a vibration that can damage the mechanical integrity of the components unless well damped. Fluttering and buffeting are the dynamic aeroelastic phenomena. First, I will explain about the buffeting. Buffeting. It is a random force vibration. Generally, it affects the tail unit of the aircraft structure due to the airflow downstream of the wing. The methods for buffet detection are: first one is the pressure coefficient diagram, second one is the pressure divergence at trailing edge, third is the computing separation from trailing edge based on Mach number, and last one is the normal force fluctuating divergence. Next is the buffeting testing. So the buffeting testing is done by the flight vibration test, that is FVT, under real flight conditions. Possible parameters that could predict the tendency of an aircraft to experience buffeting are: first one is the realistic requirements for the development of future simulation methods and test for controlling or preventing buffeting. So the next topic is flutter. Flutter is an unstable, self-excited structural oscillation at a definite frequency where energy is extracted from the airstream by the motion of the structure. Flutter is not only for the wings, but the similar sections like ailerons, spoilers are subject to flutter too. It doesn't mean excessive oscillation or wing, but also the coupling or bending of or torsion frequencies between wing and body or body and edge-tail can also cause flutter. One of the main criteria for prevention of flutter is proper gap between components frequency. The proper space is obtained and recorded after every experiment, test, and calculation. Flutter includes aeroelasticity, propeller wind flutter, and transonic aeroelasticity. Flutter prediction methods are there are three methods for the flutter prediction. First one is the P method, second is K method, and third one is the P and K method. The next topic is the flight flutter testing. The flight flutter testing is a three-step procedure, which includes the first step is the analytical prediction, second step is the flight test estimation, and the third step is that in which the decision is made to proceed to the next flight test point or not. So moving on to the next slide, so this is about its application. The aeroelasticity has application in civil structure as well as aerospace structures. In civil structures, it is mainly applied in tall chimneys, buildings, bridges, overhead cables, and flow-through pipes. And in aerospace structure, it has major part of application, that is in aircraft wings, control surfaces, in rockets, panels, and control surfaces, in gas turbine plates, and in helicopter rotary blades and fuselage system. Now we are going to talk about its future enhancements or its future ambits. Aeroelasticity is a very vibrant research topic. Even though the basic physics behind most aeroelastic phenomena was understood very early, but several types of research on this topic is still very active, aiming at higher accuracy in the prediction and increased efficiency of the analysis. For the concluding remarks, I would like to say that the scope of aeroelasticity is being defined and also provide an overview of the most important static and dynamic aeroelastic phenomena such as divergence, control surface reversion, flutter, and buffeting. Several improvements to the aeroelastic designs were also made, which includes larger, fully integrated CFD and CST aeroelastic models. Second one is aeroelastic stitching or functional aircraft structures. As aeroelasticity play an important role in designing any aircraft, this topic is an advanced topic in aeronautical engineering. It is a very fertile field for challenging research. Any query?
How to prevent fluttering?
So, fluttering can be prevented by adjusting mass, stiffness, or aerodynamics of structures, which can be done by flight flutter testing. Any other?